Yep, answer is bandwidth. Yeah. No, I don't want to hear. All right, so you guys have done it in the complete part. So I'm going to run ahead. So bandwidth turns out to be 95.5 kilohertz, which is basically you would do nothing but you would do 1 over 2 pi RC. This is going to be that side of the circuit for the yeah, and then it's going to be FC1, which is that side of the circuit, right? Or maybe the vice versa, but it's going to tell you like which one is the larger value, which one is the smaller value. Just subtract the larger from the smaller. So I'm getting an FC1 of, I'm just going to write the answer over here. 1 over 2 pi RC, that's going to be 10.61 kilohertz. The FC2 is 1 over 2 pi RC, which is again going to be 106.1 kilohertz. Just apply the formula, which is subtraction, and you will get 95.5 kilohertz. The next part was about the resonant frequency, sorry. And for resonant frequency, we know that there is a formula which is root of FC1 times FC2. Again, a straightforward application of this value and that value, you would get some answers. I don't have the answer, but it's just a multiplication of two numbers and the root of that, right? So that would be your resonant frequency. What is the answer for that, by the way? 33 kilohertz, right? All right, so yeah, that is your resonant frequency, which is 33.5 kilohertz, right? Right. Yeah. The sketch would be pretty straightforward. I would say that I have a filter starting and then going down. This is my cutoff frequency, which is 10.6. This is my 106, I think. Just use the same answers from top. There would be a 20 minus 3 dB reduction. That is the actual point that I'm trying to highlight over there. I'm getting at it 33.5. So now here's the thing. It is not a geometric center, which should be somewhere around 50. It's at 33.5. And the reason for that is because you can go over here on top again and see the circuit. It has different values for resistors and capacitors, right? So one of the circuits is trying to pull the resonant frequency to other region, and the other is trying to pull it to the other region. So it's always going to be the two frequencies in the root and multiply of that. If we would have four order circuits or something like that, we'll probably add all of them and multiply them to find the resultant value of that resonant frequency. The derivation can be done, but there is no point of doing that until and unless we know that this value, these terms can keep on increasing as soon as we add the more filters to that. All right, so that was band pass filter with just the passive components, right? I'm going to touch upon band pass filter with the active components. Any idea how can I draw that? So it's going to be an active high pass filter cascaded with the active low pass filter, right? So active high pass filter, I know that this is my op amp. This is going to be my second op amp. Oh, high pass would have a series capacitor and a resistor in parallel. If I wanted to have some gain, I can use that, but right now, just for simplicity, I'm using the principle of voltage follower. I'm not adding any gain to that, right? I'm using the same common ground bus. I'm going to use the output and apply now a low pass filter, which is going to be fed again over here. That's just a voltage follower over there again, right? So there are two circuits, which are again the active high pass and the active low pass, and when I cascade them both, I'm getting a active band pass filter, right? So from the basic understanding of the high pass low pass, we have reached to this circuit, which is a band pass filter, and it's active drawn in active component. Like something. Probably you can, and you can integrate those two as well, because the filter is just over here, right? The filtering part is just this. It's just the isolation and the gain that is coming up from there. So you can integrate these two as well, but normally you won't see that, right? Because that doesn't make any sense, because we are trying to actually go to a point where we ignore the loading effect on the circuit which is behind, right? Whatever is connected from the front side to my design of the circuit, I don't want that part of the load to be implemented on my circuit, right? My circuit has to be isolated. If I have something, it's an input and output relationship, so it's a transfer function. The output will connect and will get the desired thing which I have designed the circuit on. Otherwise, the circuit which I have designed doesn't really make sense if the output is changing my circuit values, right? So that's why we always have like the op amp coming up eventually for the segregation. Yes, we do. That will be the last step. Then we would have the different type of orders of filters, which are Chebyshev filters and all that coming up. That will be the last tutorial, I would say. Right. So this is how it would look like. I'm gonna put real quick a good design question again. It's 9:51. There are two questions I have. One is a lot trickier, and the other one is a straightforward one. Let's do the straightforward one first, because it's going to confuse you. You have two 5 kilo ohm resistors. You have to design a RC band pass filter. That's a very straightforward. We have done that. Forget about it. That's again straightforward, but yeah, let's. So you have two 10 kilo ohm resistor. You have to design a RC band pass filter which has a resonant frequency of 6 kilohertz and a bandwidth of 9 kilohertz. So it's a RC filter, which means it's passive. It's not the active portion, right? The circuit would look like something like this. We have C1, we have resistor, then we have resistor, we have capacitor, right? So this would be 10K, 10K, this would be C2. So actually you have to figure out the value of C1 and C2 in that. The bandwidth is 9 kilohertz. The FR is 6 kilohertz. whoever told me the answer for C1 and C2 first will get some leniency in the last lap. Probably a plus or a plus. At least that's what in my head is. So yeah, it's really good to be like competitive, right? Everyone is rushing now. And it's the right answer, right? So just raise your hand when you're done. I'm gonna walk through to your seats and have a look at the solution. All right, Mr. That's not correct. The extra mark is still open. Mark or two, I would say. All right, Zach. So you can do it now. I'm gonna solve it. I've got one of the answers over there. So yeah, no worries. Uh, it's just a mathematical question rather than I would say a theoretical question because it's gonna end up as a quadratic equation over there. And if you're good in solving it on the calculator directly, you can just figure out the value of two zeros that are over there, right? So your first equation is like FR is basically what's the answer? Stephen? Anyone else who got the answers? The answers are C1 is 5.3 and C2 is 1.33. Both of them are nanofarads, right?